Hi everyone, am I audible? Let me know if there is any issue in the audio. Okay, so now let's start. So in the last lecture, we have already seen many questions related to combinatorics. Okay, so today we will start with distributing objects into boxes. Okay, so basically here we have four type of templates. Okay, one is distinct whether basically we want to distribute objects into boxes. We have some objects and we have some boxes and we want to distribute objects into these boxes. This distribution we want to do. Now here we have two things. First of all, whether our objects are distinguishable or not, and whether our boxes are distinguishable or not. So here we have something called distinguishable. Okay, distinguishable, or I can say different, or I can say different. Okay, and another word is indistinguishable, or I can say identical. So you can notice that, sorry, so you can notice identical. Okay, now whether our objects are distinguishable or indistinguishable means our objects are different or same, our boxes are different or same. Depending on that, we have total four templates. We have one is different objects, different boxes. Okay, this is one template. Another template that we have is different objects, identical boxes. Another template that we have is identical objects, different boxes. And another is identical objects, identical boxes. So we have total four templates. Okay, so let's see each template one by one. This is very easy. Okay, so this has a direct formula, you can notice. So okay, this DODB, actually this DODB and this IODB. Okay, so these two have direct formula. Okay, so these two, they have direct, there is a direct formula to solve this. Okay, and these are actually easy. And okay, so and these two have no formula basically. Okay, so no simple formula, no simple formula. Let's see each how to solve these problems. Okay, so first of all, this DODB is very easy. Okay, this is your simple combination and basically simple permutation and combination you have to apply. Okay, so in this DODB, what you have to do, so remember in this DODB, okay, means different objects, different boxes. Here your objects are also different, here the objects are different, and you can notice here boxes are also different. So for example, okay, you can say example is like, okay, so distributing cards into some players. Okay, so basically for example distributing, I can say, okay, distributing cards. Okay, so distributing cards, total 52 cards are there. Okay, we have total 52 cards and these are cards are basically distinct, they are different. So you can notice these are different cards. So 52 cards distributing cards in two players. Okay, so these players, and of course players are different. Of course, two people cannot be same. So players are definitely distinct. So this is another example. You can notice DODB. Now in this DODB, remember always in this DODB, never apply any formula. You can actually directly. This is just a combination and this is simple permutation combination problem. Okay, this is basically simple permutation combination logic you have to apply. Permutation combination logic, just apply that combination permutation combination logic you apply. Okay, you don't have to remember any formula, just apply this simple logic. Okay, so let's solve one question. For example, how many ways are there to distribute hands of 5 cards to, okay, for example, let me take this example here first. Okay, so for example, let us assume we have 20 different objects. Okay, so these you have 20 distinct objects you have, and let's assume you want to distribute them to four players, okay, to 4 players, and let us assume each player must get 5. Each player gets 5. Each player gets 5 object, okay, so gets 5 object. Then how to solve it? Okay, so let's see how many ways are there. So basically, how many ways to distribute these into 5 players, 4 players, how many ways? Okay, so this is the question. Now, so let's see how to do this. This is very simple, you can notice. Okay, so first of all, each player must get 5 object. Okay, so you have player A, player B, player C, player D. Okay, so this player must get 5, this player must get 5, 5, 5. Okay, so 5 objects, this player must get 5 objects, 5 objects, 5 objects. Okay, now you can notice that what so this A must get 5 objects. So what we can do, this A should get 5 objects. There are 20 objects, this A should get 5 objects. So what I can do, I can select, okay, from 20 I can select 5. Okay, so from these 20 objects, this A should get 5 objects. So what I can do, from these 20 objects I can select 5 objects. Okay, and these I can give to A. Okay, so these I can give to A. Now, okay, once I have done this, okay, so this A has taken 5 objects. Now this A has 5 objects, so basically this A has taken these 5 objects. Now what I can do, from the remaining 15, now 15 objects are remaining. From the remaining 15 objects, okay, what I can do, I can select 5 objects and I can give to B. From the remaining 10 objects, I can select 5 objects and I can give to C. From the remaining 5 objects, I can select all the 5 objects and I can give to D. That's it. So this is your answer. Okay, if you solve this, then you will get something like this. Okay, so 20C5 multiplied by, okay, 15C5, and okay, 10C5, 5C5. So you know this is just 1. So this is just 1. Finally, here you will get like this: 20 factorial divided by 15 factorial, 5 factorial. Okay, multiplied by 15 factorial divided by 10 factorial, 5 factorial, multiplied by 10 factorial divided by 5 factorial, 5 factorial. Here you can notice these will cancel out. Okay, so these are getting cancelled out. So you can notice. So finally what you are getting 20 factorial divided by 5 factorial, 5 factorial, 5 factorial, 5 factorial. Okay, so 20 factorial divided by 5 factorial power 4. So this is your final answer. Okay, so this is how you can do all the DODB questions. So remember, again I am telling you, DODB, don't remember any formula, just simple permutation combination logic you have to apply. Okay, so apply this logic basically. Okay, just apply the logic, nothing else. Okay, so this is how you can do, because you have different people, A, B, C, D, these are different people. A wants 5 objects, so what we can do, from 20 we can select 5 and we can give to A. Okay, from the remaining 15 we can select 5 and we can give to B. From the remaining we can select 5 and give to C, and so on. Okay, so this is how you can do. Okay, is this clear to everyone? So okay, now what we can do, so let's see. Now let's see this question. So what is the answer for this? Okay, so basically, actually, let me give you a formula. Okay, I will not give you the proof, because this is just a revision session, so I'm not going to give you proof. Okay, if you want proof, then you can watch the discrete mathematics lectures on the Go Classes website. Okay, there I have explained everything with the proof. Okay, but because this is a revision session, so I'm not going to give you any proof or something. So for this DODB, what is the formula? What is the template? I will tell you. Okay, so what is the template of DODB? Let me tell you. Okay, so the template is like this. So basically you have n objects. Okay, so n distinct objects. So these are n distinct elements, and let us assume you are distributing them, these n, all these, all these, all of them. Okay, so all these n distinct elements you have. Now what you are doing, you are basically distributing them like this. Okay, so there is a, okay, you are putting n1 here, you are putting n2 here, you are putting n3 here, and so on, you are putting nk here. So but remember, there is one very important point that you should notice, that we should distribute all of them. We should distribute all of them. Okay, so what it means, so note that. Okay, note that. So we should distribute all of them, n1 plus n2 plus n3 plus and so on plus nk. This should be equal to what? This should be equal to n, means we should distribute all of them. That's the point. Okay, so all n objects. Okay, distribute all n. So this is the point. Now we should distribute all n. Okay, so that's it. Now you can, okay, now there is a formula. So how many ways for distribution? So number of ways to distribute, number of ways of distribution. Okay, number of ways of possible distribution, or I can say number of possible distributions. So I can say number of possible distributions. What is that? That is equal to n factorial divided by n1 factorial, n2 factorial, n3 factorial, and so on, nk factorial. So this is the formula that you can apply. Okay, this formula, okay, actually this formula comes from this logic, you can notice. So this here you can notice this is your n factorial, and every n1, okay, this is your 5 factorial whole square. Okay, 5 factorial whole square. Why? Because you can notice that every, okay, you have 20 objects, and those 20 objects, what you are doing 5 5 5 5. This is what you are doing. So you can notice that 20 factorial divided by 5 factorial power 4. So actually this formula comes from this logic. So this is the logic. Actually I can say this is the logic. So this is the logic that you can apply. Okay, so let's see this question. How can we solve this? Let's see this. In this question, what he is saying, so you can notice there are total 52 cards. You already know 52 cards. We want to distribute. There are 4 players, and to each player we want to give 5 cards. Okay, so there are 52 cards, and these 52 cards we can give to, we want to give to A, B, C, D. 4 players we want to give, and okay, every player must get five cards, every player. Okay, so now tell me, can I say that answer is this? Can I say answer is this 52 factorial divided by 5 factorial power 4? Can I apply this formula and can I say answer is this? Tell me, can I say answer is this? No, the answer is not this. This is the mistake. Okay, so this is wrong. Why this is wrong? Because remember, you should distribute all of them. Okay, I told you distribute all of them. So it's like this: 52 cards you are giving A, 5 cards you are giving to A, 5 cards you are giving to B, 5 cards you are giving to C, 5 cards you are giving to D, and you can think like this. Okay, the remaining cards. Okay, so the remaining cards, how many remaining cards? 32 cards. These you are giving. Okay, these you are putting extra. Okay, separate. Now you can notice these are n1, n2, n3, n4, n5. Okay, now these are n1, n2, n3, n4, and n5. Now you can notice their summation is also n. You can notice n1 plus n2 plus n3 plus n4 plus n5, that is equal to n, and this is your n. Now you can apply the formula, and the formula will say answer is 52 factorial divided by 5 factorial, 5 factorial, 5 factorial, 5 factorial, and 32 factorial. So this is the answer. Okay, is this clear to everyone? Anyone has any doubt, you can ask. Okay, so this is how you can handle the DODB template. Okay, and you can apply the logic also here. Okay, so this is how you can using the formula you can solve like this, but if you want you can apply the logic also. So basically you have 4 players, because logic is always important. Okay, so you have 4 players, A, B, C, D. These are the 4 players, and we want to give 5 cards to each. Okay, so this should get 5 cards, he should get 5 cards, he should get 5 cards, and he should get 5 cards. Okay, so everyone should get 5 cards. So you can notice everyone should get like this. Now okay, what I can say, very simple. So this A should get 5 cards. So what I can do, from 52 cards I can select 5 cards and I can give to A. Okay, now, so now this A has 5 cards. Now what I can do, from the remaining, I can select 5 and I can give to B. From the remaining, I can select 5 and I can give to C. From the remaining, from the remaining, I can select 5 and I can give to D. This is your answer. If you solve it, then what you will get? If you just try this, okay, if you solve this, then this is what you are going to get. 52 factorial divided by 5 factorial, 5 factorial, 5 factorial, 5 factorial, 32 factorial. This is what you will get, and this is our direct formula. So you can notice this is the logic. Okay, you can notice this is the logic and this is the formula, but this formula comes from this logic. So if you know this logic, then you can very easily solve the question. Okay, if there is any variation, you can also handle. Okay, so this formula cannot handle all the variation, but this logic can handle all the variation, we will see. Okay, so anyway, this is the formula that you can check. So this template is very important. I told you this is the template. Okay, so remember, this is the template of DODB, and this is very important. Okay, because we will discuss some templates. We will see what is the template of IODB also. Okay, so this is how you can okay, so this is the DODB. These must be different elements, and remember, these must be different boxes. All boxes must be different. Okay, so here these boxes, these n1, these n2, they must go to different boxes. They must go to different people. Okay, so that is the meaning. Now let's see one this question. Let's try. This is small variation. Can anyone tell me what is the answer? I want correct answer here. Can you tell me? How many ways are there to distribute 15 distinguishable objects, mean different objects, into 5 different boxes so that the boxes have 1, 2, 3, 4, 5 objects in them? Okay. So can anyone tell me what is the answer here? So this is a variation. I can say this is a variation of DODB. This is basically DODB problem because different objects, different boxes we have. So this is a DODB problem, but this is small variation in that. Okay. So can you try? You can notice that basically, okay, you have 15. Okay, so basically you have 15 distinct elements you have, and these elements you want to put in 4 boxes. There are 5 boxes, there are 5 different boxes. Okay, so you can notice these are the 5 different boxes. Okay, so 5 different boxes. Now the condition is that these boxes must have 1, 2, 3, 4, 5 objects in them. Okay, so basically one of them must have one. Okay, we don't know who, but one of them must have one of them must have two, one of them must have three, one of them must have four, one of them must have five. Is the total 15? So can you check what is the total? So here the total you can notice. Okay, so that is 15. So total is 15, you can notice. Okay, so you can notice total is 15. Okay, but so here you can notice, if you do like this, that okay, 15 factorial divided by 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, is this your answer? Tell me, is this your answer? Is this answer correct? If you directly apply this formula, this answer is actually wrong. Why this answer is wrong? Because see this answer, why this answer is wrong, let me tell you. Because we don't know in which, see, boxes are different. Okay, boxes are different. For example, this is a box A, this is a box B, this is a box C, this is a box D, this is a box E. Boxes are different, but we don't know in which box we should put one object. Maybe, okay, maybe I don't know. Okay, see, this answer is correct for which situation? This answer is correct, I can say this. Okay, I can say this answer is correct. This answer is correct when, okay, when we have fix, when we have some fix, like when we have fix, when we have fixed that a should get 1. Okay, that a should get 1, a should get 1, b should get 2, c should get 3, okay, d should get 4, and e should get 5. Okay, if okay, if in this situation you can say that answer is, this is the answer. Means I say, I want to say that a should get 1, b should get 2, c should get 3, d should get 4, and e should get 5. In this situation answer will be this. Okay, 50 factorial, 15 factorial divided by 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. But what is the variation? But we don't know which box should have 1. Okay, but you can notice, but in our problem we don't know which box should have 1. We don't know which box will have one object, which box will have one object, which will have two. Okay, which will have two, and so on. Okay, so this is the idea. So what should I do? Tell me, what should I do in this situation? The answer, you can apply the logic. Okay, so first of all, the method 1 you can directly apply the logic if you want. Okay, so you can just directly apply the logic. What is the logic? So you have, okay, a b c d e, these are the 5 people who should get 1. Okay, like which box should get one object? Okay, so select one, which box should get one object? So first let me select one object, one box. First let me select one box, let me select one box. Okay, so basically I am selecting one box, and to this box, let us assume, okay, let us assume I am selecting this box. So 5c1 means from these 5 I am selecting one box, and to that box I will give one, to that box I will give a one object. Okay, so I am selecting one box, and to that box I will give one object. Okay, so for example, if I am selecting a, then this a will get one object. Okay, Now what I am doing, now from the remaining boxes I will select one box, and to that box I will give, from the remaining I will give two objects. Then I will select one box, and to that box what I will do, I will give three objects. And then I will select one box, and then I will give how many objects? So from 9 I will give four objects. And then finally I will select the remaining, and I will give all the five objects. So this is your answer. So this method you can apply. Okay, so either you can apply this method, or another method is this. Okay, so the method 2, what is the method 2? Method 2 is very simple. Okay, so just apply this. Okay, 5 factorial, so this 15 factorial divided by 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. Now just multiply this with 5 factorial. Why we are multiplying this with 5 factorial? Because we don't know which box will take one object. Okay, like we don't know which box is going to take one object, which box is going to take two object, we don't know. So basically this will take care of everything. It's like this. Okay, you have one object, two object, three object, four object, five object. Now we don't know. Okay, a b c d e are there. Now if you do all the five permutations, if you do, then all these situations will be covered. Yes or no? So basically multiply with 5 factorial, so that all the situations are covered. What are the situations? Okay, when x is getting 1, sorry, when a is getting 1, when a is getting 2, when a is getting 3, when b is getting 4, like this. Okay, so this is how you can do. Is this clear to everyone? Tell me, anyone has any doubt in this question? So basically this is just a variation of this DODB problem. Now in this, one more variation can be created, and you should take care. Okay, so let me create one more variation. So basically again you have 15 objects. Okay, so 15 distinct objects, 15 distinct elements, and let's assume you have 5 distinct boxes. And let's assume that we want to distribute these 15 objects like this. Okay, so 2 2. Okay, and then you have 4, and then let's assume 3. So what is this? So 5. Okay, so you can just check it out. Okay, so okay, so now try this. Can anyone try? Okay, so basically this distribution we want, this 2 2 4 5 1. Okay, so this distribution we want, this distribution. Tell me what is the number of ways. Can anyone try? What is the number of ways? So what is the number of ways? So here you can notice, so basically again we have 5 boxes. So the boxes are a b c d e, these are the boxes. But our distribution is like this: 2 2 4 5 1. Okay, so this is basically our distribution. We don't know which will take 2, which will take 2, which will take 4, which will take 5, which will take 1. Okay, so here what we should do, so here again, if you do this 5 15 factorial divided by 2 factorial, 2 factorial, 4 factorial, 5 factorial, 1 factorial, if you multiply with 5 factorial, is this correct? Tell me here, is this correct? If I do like this, will this be correct? Will this be correct? Will this be correct? Can anyone tell me? In the last question we have done this because this 5 factorial was coming, because we don't know which box will have one object, two object, three object, four object, five object. Here in this situation, is this correct? So what should I do? Can anyone tell me what should I do? Here actually I should do what I should do, extra divided by okay 2 factorial I should do, yes or no? Because you can notice that okay here one thing you can notice, okay just remember, see, just apply the logic. These are a b c d e, these are five different people, these are five different people, okay. Now here if you do the 5 factorial, so this 5 factorial will take care of this is okay. Okay, for I can say for for selecting, this is for selecting who will get how many, okay, this is for selecting who will get how many, okay. So you can notice here all these are different, okay, so there is no problem here. But now here there is a problem. If I do like this there is a mistake. What should I do? We should divide by 2 factorial, we should divide by additional 2 factorial. So you can notice why this additional 2 factorial is coming, because of this 2 2 4 5 1, it's like this, okay. So you have 2 2 4 5 1, okay. Just think about it. If I do like this, let us assume I give a b c d e, and let us assume I give B, A, C, D, E. Are they different? Tell me, are they different? These two, are they different? Tell me. These two are same, right? Here you can notice these two are same. Because here also this is getting 2, this is getting 2. Here also this is getting 2, this is getting 2. So you can notice these two situations are same here. Okay, these two situations are same. So divide by 2 factorial. So we divide by 2 factorial. Okay, because we are basically double counting because these two situations are same. So that is the reason what we should do. Okay, so that reason because of that what we need to do, we need to divide by 2 factorial. Okay, so this is the answer. I hope this is clear to everyone. Let's do one more variation. Okay, so in the same question can we do this variation? Just tell me. You have let's assume you have 16 distinct elements, 16 distinct elements, and let's assume you have 4 boxes. Okay, so let's or maybe 5 distinct boxes, and let's assume this is the distribution we want. We want this distribution of elements. The distribution of element that we want is basically 2 2 2, okay, so that is 3 3, okay. So you can notice, okay, so this is the distribution we want. Tell me what is the answer now. Now tell me what is the answer. What should be the answer here? Where are the 14? Okay, 2 to 4. There are 15 elements, right? Where are we taking 14 elements? Can you tell me? Okay, 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 okay. Yeah, okay, okay. So we can make it 6. Okay, just make it 6. Just make it 6. Okay, sorry for that. So just make it 6. 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 Okay, this is correct now. Samin, thank you. Okay. Okay, so tell me what is the answer here? Here the answer will be what? So here the answer will be, it's like this, okay. So there are 16 factorial divided by 2 factorial, 2 factorial, 2 factorial, 3 factorial, 3 factorial, 4 factorial. That is fine. Okay, that is fine. Now you multiply with 5 factorial, okay. But now additional you have to additionally divide. You have to additionally divide. Okay, you have to additionally divide because of this 3 factorial and because of this 2 factorial. So you have to additionally divide with 3 factorial into 2 factorial. Okay, is this clear to everyone? See here why we are dividing 2 factorial. Is this clear? If this is clear, then you can very easily understand. If this point is clear, here we divide by 2 factorial because, okay, so let me just tell you why we divide by 2 factorial. It's like this, okay, just apply the logic. Now you can notice that you have A, B, C, D, E. These are the 5 people, and our distribution is like this. So our distribution, so just see the distribution. Our distribution is basically, this is 2 to 4 6 1, 2 to 4 6 1. Okay, so just look at the, okay, I am talking about this question. I'm talking about the previous question. Okay, so you can notice 5 boxes. So these are the boxes, 5 boxes we have. I'm talking about this question. So we have total 5 boxes and 2 to 4 6 1. I'm talking about this distribution. So here you can notice, okay, so who will get 1? So here, okay, so who will get 1? So let's select. So from 5 boxes you select 1. Okay, from these 5 boxes you select 1 box. Okay, and then what you do, you give 1 object to this box. Okay, so this will take care of 1 box. Okay, so this is your basically box containing 1 object. Okay, so this will take care of box containing 1 object. Now what you do, okay, from the remaining 4 boxes you select 1 box, and you give these 6 objects. Okay, so from the remaining you give 6 objects. So this will take care of box containing 6 objects, box containing 6 object. Okay, and then what you do, from the remaining 3 boxes you select 1 box. From the remaining 3 boxes you select 1 box, and you give 4 objects. Okay, so from the remaining you can notice, from the remaining you give 4. Okay, so this is your box containing 4 objects. Okay, now multiplied by. So now what will happen, now you can notice that now we have 2 comma 2. Okay, so here if we do like this, for example, if I do that, okay, from the remaining 2 if I select 1, see it's like this. Here what should happen now, okay, now A comma B, they must have 2 2, they must have 2 2. Now it does not matter who will take okay, like it does not matter now, because A should have 2, basically A should have 2, B should have 2. So what should I do, from the remaining objects I should select 2 objects, and I should give to this I should give to okay, one of the boxes, and the remaining I should give to another box. Okay, so this will go to a box, this will go to a box. Okay, and these will go to another box, these will go to remaining box. Is this clear to everyone? Because now A and B, they both should have what, two elements. So what should I do, A must have 2 elements. So let me select 2 elements and give to A, and from the remaining 2 elements I should give to B. So this is how you should do. Okay, now you can notice that if you do like this, then what is the problem? Let's see what's the mistake here. If I continue like this, then what's the mistake, can anyone tell me? For example, if I do here also, if I do that, okay, from two boxes I select 1 box, and then I give from, okay, if I do like this, then what is the problem, can anyone tell me? If I do like this, now here the mistake is, what is the mistake, I have double counted, because you can, okay, here what I have done, so this is actually wrong. Okay, so because this is actually wrong, so this solution, this here is wrong, because here I have double counted. What I have done, okay, so this C has taken okay, C D E. Okay, so this E has taken 1 object, this has taken 6 object, this has taken 4 object. Okay, so but you can notice now you can notice that A should take 2 object and B should take 2 object. Now if you do like this, if you select here at this point of time, if you select from 2, if you select 1 box, and okay, you give like this, okay, multiplied by 1C1 multiplied by 2C2, then here you are double counting, here we are double counting. What we are doing, double counting. Okay, and the double counting is happening like this. Okay, here what is happening is For example, let us assume A is getting A1, A2 and B is getting B1, B2. Okay, and you can notice, so here if you are selecting A here, then in another situation what will happen? In another situation this will happen, that A will get A1, A2 and B will get B1, B2. So that is the reason the same situation you are counting two times. Is this clear to everyone? Let me know. So that is the reason we are dividing by 2 factorial. I hope this point is clear. Or you can apply the logic. If you apply the logic, then also you will get the same answer. And here what we have, so these are 2, 2, 2. So that is the reason 3 factorial I am dividing, and this is 3, 3. So I am dividing by 2 factorial so that I do not do any over counting. Is this clear? Anyone has any doubt? Let me know. Okay, so let me just write. Okay, so this is the final conclusion. Let me write. Okay, so actually from these variations you can see the final conclusion. Okay, so there is no need to write the final conclusion, but from these variations you can cover all the variations that are possible. I have covered. Okay, order of distribution doesn't matter. No, yes, here order of distribution doesn't matter. Okay, let's see this question. Can anyone tell me what is the answer? Distribute n distinguishable balls into n distinguishable boxes. Okay, and any box, and okay, like there is no limit. So basically you have n balls, you have n different box, n distinct balls you have. So tell me what is the answer now? N distinct balls to n distinct objects. There is no limit. Who will get how many? There is no limit. Then tell me what is the answer? For example, if I ask you this question, okay, for example, this is my question. Let's assume you have 5 letters, and okay, so 5 letters you want to, five distinct letters you have, and you want to post them in for post office, for post office. Okay, now tell me, then how many ways are there? How many ways? There is no limit. You can notice. Okay, there is no limit. Then tell me how many ways are there here? 5 letters you want to distribute into. Okay, so which option is correct? Tell me, 5 power 4 or 4 power 5? Which option is correct? In this question, which option is correct? 5 power 4 or 4 power 5? 4 power 5. Here you can notice 5 different letters I have. Okay, so for each letter I have 4 choices, or for each post office I have 5 choices. Can anyone tell me? So here just decide what you are distributing. You are distributing letters. So for each letter you have 4 choices. Remember, each letter has 4 choices. Okay, so remember this, each letter has 4 choices. So this is very important, that here you are distributing letters. So each letter has 4 choices. Okay, remember this is correct. Each post office doesn't have 5 choices. Okay, don't say that each post office has 5 choices. Each post office has 5 choices. No, this is wrong. Okay, so you are distributing letters. Remember, we are distributing letters. We are not distributing post office. We are distributing letters. We are distributing letters. So you can notice each letter, whatever letter you take, L1, L2, L3, L4, L5. So each letter has how many choices? Total 4 choices. This has total 4 choices. Once you put this, again this has 4 choices. 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 So finally I can say that finally answer will be 4 power 5. Okay, so here answer will be 4 power 5, not 5 power 4. Okay, so this is the answer. So similarly here you can tell n distinct balls you have, n distinct, let's assume you have m boxes. Then what should be the answer? Okay, so let's assume you have m. Here you have m. Then what should be the answer? So here the answer should be basically m power n, because every ball has m choices. Here you can notice every ball has m choices. Okay, so the answer will be m into and so on, n times. Okay, so like this you can do. Okay, so anyway, these are all the variations that we can see in the DODB. So we have seen all the variations that are possible in the DODB template. In the DODB case, every possible variation I have told you. So anyone has any doubt in any variation? All possible variation we have seen, all variations we have done. Anyone has any doubt in any variation of DODB? All the variations we have done. Anything that they can ask you in this DODB, we have seen. Okay, here in this DODB, one more variation is remaining, so you can check this variation is also coming. For example, if I give you success, okay, so how many permutations are there? How many permutations? This is also DODB case actually. Permutations. How many permutations? So this is also same. Here also you can notice here. Basically, we have 3s. So how this is DODB? Can anyone tell me? How this situation is DODB? We have success, okay, and how many permutations are there? I am saying that this is also DODB case. This situation, this is also DODB case. How this is DODB case? How this is DODB? What are the objects and what are the boxes? Can anyone tell me? This is also DODB case. Anyone? What are the objects and what are the boxes? So here actually the boxes are the letters. Okay, so the boxes are, these are the letters. So S, U, C, E. These are the letters. These boxes are the letters. First of all, here the boxes are letters. Okay, S, U, C, E. These are the 5 boxes. So you can notice these are the 5 boxes. Okay, and what are the can anyone tell me what are the objects here? What are the objects? Can anyone tell me? Anyone? What are the objects? The objects are the positions. The objects are the positions in the permutation. Okay, the objects are the, so it's like this. For example, just tell me, if I give you this SUCE and let us assume I give you this, then tell me which permutation will be there. Okay, for example, here you have 1 2 3 4 5 6 7. Okay, so let me give you 1 3 4, and let me give you, okay, so success, let me give you 5, and let me give you CC, so let me give you 2 comma 6, and let me give you 7. Now tell me, if I have this distribution, then what is the permutation? For this distribution, what is the permutation? Can anyone tell me? Anyone want to tell me, for this distribution, what is the for this distribution, this is the distribution, this is the distribution. For this distribution, what is the permutation? The permutation is S, C, S, S, U, C, E. This is the permutation. Yes or no? Is this clear to everyone? So you can notice that this is also a DODB case, because any, if you have, for example, if you have this UCSSS, okay, and let's assume CE. For this, what will be the distribution? Okay, for this the distribution will be like this, SUCE, and the distribution is simply, where is S? Okay, so that is 2, okay, 3 4 5, these positions, and U is first position, and C is second position, and E is seventh position. Okay, so so C is basically second position and sixth position. So you can notice this situation is also DODB case, and in this case you can notice that your boxes are the letters and your positions are the objects. Okay, so finally here you can notice that this is what I want, success. Okay, success permutations I want. How many permutations? This is what I want, how many permutations? So this problem, now this is just simple. Okay, you have 4 boxes, and in these 4 boxes, what we want? Okay, so we want to give 3 positions here, and we want to give 1 position here, we want to give 2 position here, and we want to give, okay, 1 position here. Now this, for this the answer will be, for this the answer will be 7 factorial divided by 3 factorial, 1 factorial, 2 factorial, 1 factorial. This is your DODB answer. Okay, so these two problems, this problem and this problem, this now this is your DODB problem, you can notice. So now this is just a DODB problem. Okay, so this is how you can solve. Anyway, so these are all the DODB templates. So finally this is done. Okay, this DODB, all variations, all templates, everything is done. Is this clear? Now let's see the very important, that is IODB. Okay, so this is very important. Actually this is more important than DODB. So what is IODB? Means objects are same but boxes are different. Okay, so in this case what we will do, so remember, first let me tell you what is a star bar problem. Okay, so okay, let me ask you one question. Let us assume you have n stars. Let's assume you have n stars, and let's assume you have r bars. Then in that case, can anyone tell me how many permutations will be there? How many permutations will be there? So you have n stars and r bars. So basically you have n stars. Star means you can notice it's like this. Okay, so you have stars. So total n stars you have, and total r bars you have. Then tell me how many permutations are there? How many permutations? So number of permutations will be what? For this question, number of permutation will be what? Number of permutation will be n plus r CR, yes or no? Here the answer will be what? N plus R CR, or you can say N plus R CN. Okay, or you can say N plus R factorial divided by N factorial R factorial. Yes or no? So this is the answer, correct? Okay, N plus R factorial divided by N factorial R factorial, or you can say N plus R CR, or you can say N plus R CN, because you already know this thing. You already know that NCR, this is equal to NCN minus R. This you already know. Okay, so that is the reason I can say that N plus R CR, this is equal to N plus R CN. Okay, so this you already know. Now finally, so if you have n stars r bars, then these many permutations you can make. Okay, and this IODB, every IODB template is star bar problem. Remember, every IODB problem. So this is, if you understand star bar, then you can understand every IODB template. So every IODB problem is a star bar problem. This is equivalent to star bar problem. Equivalent to star bar problem. So this is your star bar problem. This is the star bar problem. So you have n star r, sorry, you have total n star r bar. Then how many permutations are there? This is called, this problem. This problem is known as star bar problem. Okay. So the name of this problem is star bar. Now finally, okay, so this is, now every IODB template will follow this star bar problem. Okay, every IODB template, whatever you take. So what are the templates under this IODB? So let me tell you, and this is very important. So let's see. Okay, so okay, so let me just remove okay, so like this. Anyway, so you can notice these are the, so okay, now this, so this is star bar problem. Is this fine now, Rajan? Is it fine? Tell me. So anyway, so let's go now. Finally, okay, remember IODB template. So let me tell you IODB template. IODB template. What is this IODB template? In this IODB template, remember, boxes are, so first of all, boxes, objects are different. So remember, sorry, objects are same, I can say objects are all same, identical, and boxes are different. Boxes are different. So the template is this. At any point of time, if your problem is like this, if you can write your problem like this. Okay, so remember, objects are same, all the objects are same, boxes are different. Okay, so at any point of time, at any point of time, so objects are same, basically, I can say. Okay, so now what I'm saying, at any point of time, if this you find, for example, if this you find, for example, okay, x1 plus x2 plus and so on xr is equal to n. If you find this type of equation, okay, if you ever find this type of equation, and if you have to find the solution of this equation, okay, at any point, remember this is the iodb template. Iodb template means at any point of time, in any problem, whatever problem they give you in the gate exam, okay, if you can make this template, if this problem follows this template, means x1 plus x2 plus xr, so these are the variables and equal to n. Okay, so if you have to find the so basically if you have to find the basically solution of this equation, I can say, okay, non-negative integer solution of this problem, non-negative integer solution of this problem, integer solution, okay, then you can apply the iodb template. So here what will happen, here actually these are the boxes, this x1 x2 x3 xr, okay, so these are the boxes, and this n, these, okay, so these are the stars. So first of all, these are the stars, these n are the stars, and these are the boxes, these are the boxes, and these are the bars. So how many bars we have? So you can notice how many bars we have. So total n stars we have, and if you have total r boxes, then r minus 1 bars we have. Yes or no? Because how many boundaries? Bars means boundary basically. How many boundaries we have? So you can notice, if you have this type of equation, then the answer will be what? So number of solutions, number of non-negative integer solution, number of non-negative integer solution, what that will be? This is now star bar problem, n star r minus 1 bar, n star r minus 1 bar. So this will be your answer. Tell me, is this clear to everyone? So remember, this is the template, very simple. At any point of time, if you have to, if you can write this equation, and if you have to find this solution, then you can just very simply find out. So these are the stars, n stars, and r minus 1 boundaries, or you can say bars. So r minus 1 bars. So finally, number of non-negative integer solution will be n plus r minus 1 c n. Okay, so let's see what are the problems that fall under this category. For example, if you have, see, okay, directly iodb template, 10 identical balls and 8 different ball. Okay, so this is the question number 1. Tell me, 10, okay, identical balls, 10 identical balls, and you have 8 different boxes, 8 different boxes. Then tell me how many ways will be there. Number of ways, number of distributions. So you have 8, 10 identical. So this is simply iodb, yes or no? From the problem you can notice this is just iodb, because you have identical balls and you have different boxes. So this is just iodb. So here you can apply the very simple formula you can apply. So these are the boxes, boxes are b1, b2, b3, and so on, b8. These are the boxes, and what we want that their summation must be equal to 10. Okay, so these are your balls. Okay, so these are the balls, and these are, okay, so you can notice these are the boxes. So finally you can notice here the how many boundaries we have. So total 7 bars we have, 7 boundaries we have, and 10 stars we have. These are the stars. And so finally answer will be, okay, so 10 plus 7 c 7. So this is the answer. Yes or no? So the answer will be 17c7, or you can say 17c8. So the answer can be this or this, 17c7, 17c8. They both are correct. Okay, so this is how you can do. Now let's see another problem. Consider this. How many ways are there? Okay, b identical balls and u different. Okay, so this is also iodb problem. You can notice this is also iodb problem. So here what is the answer? How many stars, how many bars? Just tell me this point. So you can notice boxes, u boxes you have. Okay, so box b1, box b2, and so on, box bu. So bu boxes you have. So how many bars you have? So number of bars. So you have basically u minus 1 bars you have. And okay, the total must be b. These are the stars, these are the stars. So finally you have u minus 1 boundaries and b bars. So finally answer will be b plus, okay, so this, okay, or you can say b plus u minus 1 c u minus 1. So this is how you can do. Is this clear to everyone? Now this is another combination with repetition also follows the same template. Okay, combination with repetition. For example, consider this question. Let's consider this question. So you have basically the question is saying that you have apples, oranges, pears. Okay, and what we want. Okay, so basically the question is saying we want total 15. Okay, how many ways are there to select four pieces of fruit? Okay, so total four we want, and there are three categories. So you can notice there are apples. Okay, there are oranges. Okay, and there are, okay, pears. And okay, so these are the three categories, and total we want is four. Remember, total we want is four, and these are the three categories. Okay, and total how many fruit we want is four. For example, I can take, okay, for example, I can say 0, okay, 2, 2. This is a solution, right? For example, or I can say 2, 0, 2. This is another solution. For example, 1, 1, 2. This is another solution. So you can notice that this equation we have this equation: apples plus oranges plus pears equal to 4. Total we want 4. Okay, is this clear? So finally, this is also your IODB template. You can very easily see this is also IODB template. Okay, remember, it does not matter how many what are the apples. All the apples must be identical. Only this number matters. Only this number matters. It does not matter which two apples you are taking. So only this number will matter. Remember, it does not matter which two apples you are taking. It does not matter which two pears you are taking. Only this number matters. So here you can notice this is your IODB template. So finally, how many bars you have? So total 3 bars you have, you can notice. Okay, so sorry, 2 bars you have, and total 4 stars you have. So finally answer will be 4 plus 2 C2, or you can say 4 plus 2 C4. So the answer will be 62 or 64. This is another question. How many solutions this equation has? Non-negative integer solution for this equation. Again, the question is very simple. How many bars? Again, you can very easily find how many bars. So you can notice these are the bars. So you can notice 2 bars we have. Okay, so finally 2 bars we have, and 11 stars we have. So from here you can notice that answer will be what? Third. Okay, answer will be this plus C2, or this is equal to, okay, you can say 11 plus 2 C11. So this is how you can do. And multi-set problem is also will also follow the same template. Okay, so let's find out. Tell me, if I ask you this question, then tell me, will it follow the same template? For example, this is a multi-set. Remember, in a set, actually this 1 comma 2, this is same as 1 comma 1 comma 2. These two are set. Okay, in a set actually repetition is not allowed. In a set we cannot do repetition not allowed in a set. Okay, so actually these two are same set. Okay, so if I say that set, this is a set A. Let us assume, if I say that this is a set A, this is A comma B, and if I say that this is a set B, and which is A B B B B, then you can notice, then you can notice that set A is equal to set B. Okay, because in a set repetition is not allowed. Actually this set is actually same as A comma B. Repetition is not allowed. But in what is a multi-set? What is a multi-set? Multi-set repetition allowed. Basically this is a set with repetition, set with repetition allowed. So this is just a set with repetition allowed. So you can notice that if I say that these are multi-set, if I say that you have a multi-set A comma B, and if I say you have a multi-set B, which is A comma B, now you can notice these are not same. Now these are not same. Okay, because in a multi-set repetition is allowed. So that is the reason these are different. Actually these are different multi-sets. These are different multi-sets. Okay, so what should I do? If I ask you this question, then what should be the answer? For example, let us assume you have a set A. Okay, 1 2 3. This is a set. Okay, from this set how many multi-set of size 5 I can create? Okay, so from A, how many multi-sets of size 5? How many multi-sets of size 5 I can create? Tell me, how many multisets of size 5 we can create. The only difference is multiset means a set with repetition allowed. Order does not matter. In a multiset also order does not matter. This is just a set with repetition allowed. So if I ask you, this is the set A, okay, then what, tell me, tell me. Okay, so first of all you just focus that what is this. Okay, just see what is this asking. So you have a set A, and in this set A the question is saying from A how many multisets of size 5 you can create. For example for example 1 comma 1 comma 2 comma 2 comma 3, this is a multiset of size 5. For example 1 comma 2 comma 2 comma 2 comma 3, this is a multiset of size 5. Okay, for example 1 comma 1 comma 1 comma 1 comma 1, this is a multiset of size 5. Okay, 2 comma 2 comma 2 comma 2 comma 3, this is a multiset of size 5. So we have to count all of them. We have to count this, we have to count this, we have to count this, we have to count this. So we have to count multiset of size 5. We have to count how many multisets of size 5 are there. So how many multisets are there of size 5? See, in a multiset you can notice the only thing matters is how many ones you are taking, how many twos you are taking, how many threes you are taking. Yes or no? Yes or no? The only thing that matters is how many ones you are taking, how many twos you are taking. For example, if you have this multiset 1 1 2 2 3, then this multiset I can say that in this multiset basically what is happening? In this multiset basically this is happening. In this multiset how many ones you have taken? In this multiset basically 2 ones you have taken, 2 twos you have taken, and one, okay, one you have taken. For example this multiset, consider this multiset. In this multiset what you have done? In this multiset you have taken 5 ones, 0 twos, 0 threes. Yes or no? And for example if I say basically total must be 5. If I say that you have 2 0 3, then what you will get? Then the multiset that you will get is 1 1 3 3 3. Yes or no? So basically this multiset also follows the IODB template. You can notice basically it matters how many ones you are taking, how many twos you are taking, how many threes you are taking. This matters, how many ones you are taking, how many twos you are taking, how many threes you are taking. Yes or no? Only this matters. And this, okay, how many ones, how many twos, how many threes. Yes or no? Only this will matter. So basically the number of ones, I can say number of ones. Here we have, okay, here we have number of ones, number of twos, number of threes, and the total must be equal to what? The total must be equal to 5. Is this clear? The total must be equal to 5. This plus this is equal to 5. So you can notice that this multiset also follows the same template, IODB template. Okay, so that is the reason answer will be what? So you have two bars. So here you can notice that you have total, okay, so total two bars you have. So these are your stars, I can say. So these are the stars and these are the two bars. So finally answer will be 5 plus 2C2, or I can say 5 plus 2C5. Okay, so the answer will be 7C2. Is this clear? So all these problems that we have seen, they follow the same template, IODB template. So you can notice not the following are equivalent. Okay, IODB template is followed by all these problems. No negative integer solution, multiset problem. Okay, this is your multiset problem. So multiset will follow the same template. Non-negative integer solution will follow the same template. IODB will follow the same template. You can notice, okay, IODB will follow. This means IODB. This IODB will follow the same template, and combination with repetition will follow the same template. Okay, so you can notice combination with repetition. Combination with repetition will follow this. So all these four problems are following the same template. Okay, and this is another problem which is following the same template. This I will tell you after some time. But the number of positive integer sequence a1 a2 ak, where, okay, so this I will tell you. I will take one example. This is based on this, there is a gate question. There is a gate question in which this has come. So anyway, these five problems, they follow the same template. Okay, let's solve this question. This is your gate exam question. Can anyone tell me what is the answer? Anyone? What should be the answer for this gate gate question? So you can notice the question is very simple. In how many ways a positive integer can be expressed as sum of two positive integers? So how many ways are there? So when you read the question, just focus what is this template. Okay, in which category this question falls. So if you notice this option A, this is basically IODB template. If you notice in this option A, what he's saying? Option A, he's saying that how many ways. So basically this n can be written, how many ways are there such that this n can be written as sum of two positive integers, sum of two positive integers. Okay, so a1 comma a2 must be positive. Here a1 comma a2, they must be positive, positive integer. Okay, so this is the question. So basically we have to find the how many solutions are there for this equation. For example, if you have a1 plus a2 equal to 3, then what are the solutions? 1 comma 2 is a solution, 2 comma 1 is a solution. So okay, so two solutions are there. Okay, now if you have n, a1 plus a2 equal to n, positive integer solutions we want positive integer solution, means a1 must be greater than equal to 1, a2 must be greater than equal to 1. So what should I do? I know the answer for non-negative integer solution. I don't know answer for positive integer. See, if the question is this, a1 plus a2 is equal to n, where a1 comma a2, they both are greater than equal to 0, means non-negative integer, means non-negative integer. Okay, so if this is the question, then the answer is very simple. Now in this situation, this is the whole situation. This situation is basically IODB situation. Okay, this is the IODB situation. And so answer you already know that n stars and one bar you have. So here you how many? Okay, so there is only one bar and there, okay, so you can notice there is only one bar and total n stars you have. So finally here answer will be n plus 1 C1, which is nothing but equal to n plus 1. So this is the answer. Okay, if this is the situation, means a1 a2 means they are greater than equal to 0, means non-negative integer solution problem. I know the answer for non-negative integer solution problem, but this is positive integer solution problem, means a1 must be greater than equal to 1, a2 must be greater than equal to 1. So what should I do? This is very simple, because a1 must be greater than equal to 1, so give 1 here, so put 1 here, yes or no? Because a1 must be greater than equal to 1. So what I can do, this is how I can do, I can just directly give 1 to a. Okay, I can directly give 1 to B. So here what should I do? So what should I do? Actually, I should directly give 1 to this. From this n, I should give 1 to A1. Yes or no? So here I can say that, okay, directly give 1 to A1, okay, and directly give 1 to A2. Now how many are remaining? So now I have A1 dash, A2 dash is equal to n minus 2. Now n minus 2 are remaining. And now the question is very simple. Now these a1 dash, this should be greater than equal to 0, and this a2 dash must be greater than equal to 0. Now the answer is n minus 2, these many stars and 1 bar. Okay, so from this you can very easily see the answer is n minus 2 plus c, okay, 1, and that is equal to n minus 1. Okay, is this clear? Anyone has any doubt in this? Remember, IODB means non-negative integer solution problem. Okay, but in this question, the question is asking for positive integer solution problem. So that is the reason what we are doing. From this n, we are giving directly 1 to a1 and we are giving directly 1 to a2. So how many are remaining? Remaining are n minus 2. These are the remaining. Okay, now you can notice n minus 2 stars and 1 bar. So this is the answer. Tell me what is the answer for option B. In the option B, basically you have summation of three integers. Okay, so option B is also very simple. In this you have a1 plus a2 plus a3, this would be equal to n. And remember here condition is a1 must be greater than equal to 1 and a2 must be greater than equal to 1, a3 must be greater than equal to 1. So what should I do? I should give directly 1 to him, directly 1 to it, directly 1 to it. So what I will get? I will get a1 dash plus a2 dash plus a3 dash. This is equal to, remaining is n minus 3. So what is the answer? Total 2 bars I have. So we have 2 bars and you have n minus 3 stars. Okay, so finally answer will be n minus 3 plus 2 C2. Okay, so this is the answer. Means basically n minus 1 C2. This is your answer. And what is the answer for option C? For option C, okay, as sum of k positive integers. Sum of k positive integers. So option C means basically it's like this: a1 plus a2 plus ak. This is equal to n. Again, what should I do? Again, I should give, because remember each ai is greater than equal to 1. So what should I do? To each ai I should give 1 directly. Okay, so give 1 directly to each ai. So what you will get? You will get a1 dash plus a2 dash and plus ak dash. This is equal to, how many are remaining? If I give 1 to it, 1 to it, 1 to it, then how many are remaining? N minus k. This is the remaining. So finally this is your remaining. Okay, so these are your stars. And how many bars? So you can notice that total k minus 1 bars you have. And so finally here you will get n minus k plus k minus 1 c k minus 1. So this is the answer. Okay, n minus 1 c. So basically final answer will be n minus 1 c k minus 1. This is the answer. Is this clear? Okay, this is another gate exam question. You can notice in the gate exam many times this type of questions have come. Many times, multiple times this IODB questions have come. Okay, so this is gate 2002 question and this is gate 2003 question. Both are dependent on, basically both are you can notice both are from IODB. So what is the answer? M identical balls are placed in n distinct bags. So this is IODB. Okay, and you can notice that in how many ways these can be placed, so that every bag has at least k balls. Every bag must have at least k balls. So it's like this: you have bags b1 plus b2 plus b. Okay, so how many bags you have? N bags you have. Okay, and total how many balls you have? Okay, m balls you have. Now the question is saying that every bag must have at least k balls. Okay, so this bag, every bag bi must have at least k balls. At least k balls. So what should I do? Can anyone tell me what should I do? See, I have n m balls. I have m balls identical. Okay, and these are the boxes. These are the boxes, n boxes, and every box must have at least k balls. So what should I do? I should directly give k balls, because all are identical. All the objects are identical. So because all the objects are identical, you can directly give k balls to it, k balls to it, k balls to it. So finally what I will need, what I want. So finally I have, okay, so this is what I have. This should be equal to, so how many I have given? I have given nk. So finally I have this equation I have. Now you can notice, now finally you can notice that bi dash is greater than equal to 0. So here you can just apply. Again, this is the stars, these are the stars, and how many? Total n minus 1 bars you have. So finally answer will be what? Answer will be m minus nk plus n minus 1 c n minus 1. So this is the answer. Okay, any doubt anyone? This IODB is very important. Many questions have come from this IODB template. Okay, and I told you the template is very simple. This is the simple template. The template is like this: at any point of time you have x1 plus x2 and so on, xr is equal to n. Okay, so if you want non-negative integer solution here, if you want non-negative integer solution, means xi is greater than 0. So you want non-negative integer solution, then what should happen? So here the answer will be what? So basically number of non-negative integer solution, non-negative integer solutions, that will be equal to, remember these are the stars, and how many bars you need? Here how many bars you have? Okay, so you can notice total r minus 1 bars you have. So here you can notice total r minus 1 bars you have. So finally n stars and r minus 1 bars. So finally I can say n plus r minus 1 c r minus 1, or you can say n plus r minus 1 cn. So this is the template. Okay, now you can make a template for uh, if I ask you, okay, let's solve this question. Can you try this? Can anyone tell me what is the answer for this? X1 plus x2 plus x3 is equal to 15, where x1 must be greater than equal to 2, x2 must be greater than equal to 3, and x3 must be greater than equal to 0. So can anyone tell me what is the number of what is the number of solutions? Number of integral solutions. Tell me. Where x1 must be greater than equal to 2, x2 must be greater than equal to 3. So how many integral solutions are there? Means how many solutions are there? Can anyone tell me? Anyone want to try? Number of solutions. See, very simple, because x1 must be at least 2. X1 must be at least 2. So directly put 2, okay, directly give 2 to x. Okay, so x1 must be directly, okay, you need to do? To x1, you directly give 2. So to this x1 you directly give 2. To this x2 you directly give 3. So what's finally what I have? I have x1 dash plus x2 dash plus x3. Okay, I have directly given 2 to x1. I have directly given 3 to x2. So finally how many are remaining? 10 are remaining. Now these are the stars. So basically 10 are the stars, and you can notice 2 bars. So 10 stars, 2 bars. So finally what is the answer? So the answer is simply, okay, 10 plus 2 C2. This is the answer, 12 C2. Okay, so the answer will be what? 12 C2. Yes or no? Is this clear to everyone? Tell me. Anyone has any doubt? Okay, so let's see this GATE 1999 question. What is the answer? Anyone want to try? Two girls are there who have picked 10 roses, 15 sunflowers, and 15 daffodils. Okay, so what is the number of ways they can divide these flowers among themselves? So what should be the answer? So for this question, what will be the answer? So you can notice basically these two girls, there are two girls and they have 10 roses, they have 15 sunflowers, they have, and 15 these, okay, 15, okay, whatever. So basically two girls you have G1 G2, these are the two girls, and what they have? So they have 10 roses, they have 15 sunflowers, okay, 15 sunflowers, and they have 15, okay, some, okay, whatever, this is okay. Now they want to distribute them, they want to distribute them. Then what should happen? Then how many ways are there in this question? Okay, can anyone tell me, these roses, they depend on sunflower or not? Do they depend on sunflower? These roses, do they depend on sunflower? No. So you can separately distribute them, you can separately distribute them, and you can separately distribute them. Okay, so roses you can separately distribute, and sunflowers you can separately distribute, and this def you can separately distribute. Okay, let's see how to distribute roses. So the roses you can distribute like this, G1 plus G2. Okay, means roses. So okay, let's see the distribution of roses. So for roses, how many ways are there? So this G1 plus G2 must be equal to 10. So for roses, how many ways are there? Very simple. Here the answer will be 10 plus 1 C1, because 10 stars. Okay, and you can also basically you have 10 stars and you have one bar. So the answer will be 10 plus 1 C1, which means that is simply 11. So this is the roses distribution. And what is the sunflower distribution? So G1 plus G2, the total must be 15. Now here you have 15 stars, and here you have one bar. So here the answer will be what? The answer will be 16 C1, and which is again 16. And then finally this def, okay, Now what you can do, again this g1 plus g2 must be equal to 15. Again here the answer will be what? That answer will be also 16. Now you have to do this and this and this. So remember, now you have to distribute roses, you also have to distribute, and you also have to distribute sunflower, you also have to distribute these. How many ways to distribute them? That is 11. How many ways to distribute them? That is 16. How many ways to distribute them? That is 16. Now you can apply the product rule. The answer will be 16 into 16 into 11. Okay, so the final answer you can notice. Okay, so the final answer is 11 into 16 into 16. So this is your final answer for this question. You can just check it out. What is the answer? Okay, so remember in this question, this is a very simple question, but in this question you can notice you have roses, you have sunflower, you have, okay, these. So they, you can separately distribute them, you can separately distribute them, you can separately distribute them. Yes or no? So this is the point. So finally, what you can do, you can just multiply. You have to distribute roses, you have to distribute sunflowers, you have to distribute these. So this is your answer. So you can notice many questions on this IODB template. This is GATE 2000 question. What is the answer? This is a multi-set problem. I told you multi-set problem follows. Okay, so you know that multi-set problem. You know multi-set counting. You know multi-set counting is same as IODB. Is same as combination with repetition. Okay. So this is your multi-set counting. Multiset is an unordered collection of elements where elements may or may not repeat any number of times. The size of multiset is the number of elements in this counting repetitions. What is the number of multisets of size 4 that can be constructed from n distinct elements so that at least one element occurs exactly twice? At least one element occurs exactly twice. Okay, so this is the question. How many okay, so first, okay, how many multiset you can create? So basically, how many multisets can be constructed from n distinct elements? Here, how many multisets of size 4? Maybe, okay, maybe this is size 4. How many multisets of size 4 can be created, constructed from n distinct elements? Because else this will be infinite. So you can notice here. So if you have n distinct elements, so let's assume these are the elements A1, A2, A3, AN. These are the elements. And you, what you want? You want multiset. From these elements, you want multiset. You want multiset of size 4. Okay, so for example, you can notice that this is a multiset of size 4. This is a multiset of size 4. You can notice this is also a multiset of size 4, and so on. So like this. So you have to count the number of multiset of size 4. How many multisets of size 4 you can create? So multiset counting you have to do. Okay. So again, this is a very simple point because you have A1, A2, A3, and so on. So finally, what is the total? The total you want is 4. Okay. How many A1s you are taking? For example, here I am taking 4 A1s. Here I am taking 3 A1, sorry, 2 A1, 1 A2, and 1 A3. So here you can notice that total I want 4. Total I want 4. Okay. So now this is just a IODB template. So how many stars? So you can notice total 4 stars you have and total n minus 1 bars you have. So from here you can notice that answer will be n minus 1 plus 4 C4. So the answer is n plus 3 C4. Okay. So this is your answer. If there is no condition, see this is the answer for, I can say this is the answer for option B. For option B, this is the answer. Now for option A, what is the answer? The question is saying at least one element occurs exactly twice. What should I do now? Okay, so you have again A1, A2, A3, and so on, AN. And the question is saying total must be 4, but at least one element must have exactly twice. Okay, so it means there must be at least, okay, there must be 2 here. Somewhere you must have 2. Somewhere you must have 2. At least one element must occur twice. So here what you can do? Here you can basically create a case. So what are the 2 cases possible? See, you must have 2 somewhere. You must have. Okay, I don't know where, but you must have 2 somewhere. Now what are the possibilities? What else are the possibilities? The possible distributions. What are the possible distributions? So you must have 2 somewhere. Now either you can do, okay, what you can do, you must have 2. Now the remaining 2, where you can go? Okay, so this 2 is here. Now where can, okay, now either you can have this type of scenario, or you can have this type of scenario, or you can have what else? Can anyone tell me? Is there any other scenario possible? Either you can do 2 2, or you can do 1 to 1. Only these two scenarios are possible. Yes or no? Only these two cases are possible. Is this clear to everyone? Because you must have at least one element. At least one element must occur exactly twice. Okay, at least one element must occur exactly twice. So that is the point. So just count how many these and how many these. So let's count. Okay, so for this 2 comma 2. Now what you do here? From these n elements, you select two elements. From these n, you select two elements and you take them 2 2. Okay, so very simple. For example, if you select these two elements, then you will take A2, A2, A3, A3. Okay, and how many for this? From these n elements, you select one element. That element you take 2, that element you will take 2, and the remaining elements automatically what you will do? Okay, so from these n elements, you select one element, that will be 2, and from the remaining elements, you select two elements, they will be 1 1. So this is your answer. Answer is nc2 plus this. Okay, so for option, okay, that is nc2 plus nc1 into n minus 1 c2. So this is your answer. Okay, so the answer is nc2 plus n minus 1 c2. This is your final answer for option A. Is this clear to everyone? What I am saying? See, the question is saying that at least one element must occur exactly twice. Okay, so here what I can say? I can say these are the cases possible, because you must have two. Now these are the cases possible, either 2 2 or 1 to 1. Okay, so if you have 2 2, then what is the answer? Then answer is NC2. Okay, is this clear that you must have these two cases? Asis, is this clear? So either you should have this case or you should have this case, because the question itself is saying at least one element must have exactly twice. At least one element must occur exactly twice. So you must have these two must be there. Now the remaining two, because you have total 4, you want total 4. So the remaining two, you can either give 2 2 or you can give 1 to 1. Now let's see what is the answer for this 2 2 situation. Okay, so what is the answer for this 2 2? So basically you want to give 2 to one element, you want to give 2 to one element, and you want to give 2 to another element. This is what you want. Then what you can do? See, total n elements are there. From those n elements, you can select one element. Sorry, from those elements, you can select two elements. Okay, let us assume you are selecting. Let us assume you are selecting a1 comma a3. Let us assume you are selecting a1 comma a3. If you are selecting a1 comma a3, from n elements you select two elements. If you are selecting a1 comma a3, now to this a1 you take two time, and this a3 you take two time. So from these two elements, what you will make? From these two elements, this is what you will make. Yes or no? This you take two time, this you take two time. So only these many ways are there. Yes or no? Is this clear, Asis? Because you must have two elements and then two elements. So finally, what I can do, from n elements I can select two elements. For example, if I select, let us assume I select a1 a3, then what it means? It means that a1 is two times, a3 is two times. Tell me, Asis, is this point clear? Now similarly, you can notice, okay, 2 you are giving to a1, ai, aj, and ak. Here also what will happen? Here also, from n elements you select one element and you give, this is your ai. Okay, this is your ai. Okay, you give it 2. From n elements you select ai and then you give 2, and the remaining will take 1 1. Okay, from the remaining you select two elements and you give them 1 1. Yes or no? Anyone has any doubt in this? So this is a very nice question, and this is how you can solve it. So you can notice IODB problem is very important, and this is another gate exam question. This is also based on IODB. That is the reason I am telling you IODB is very important. Many questions from IODB template have come in the gate exam. Now this question also follows the IODB template. Okay. So what is the answer here? The number of four-digit numbers. Okay, so see, just read the question. The number of four-digit numbers having their digits in non-increasing order, non-decreasing order, okay, from left to right, constructed from this set. So what should be the answer? First you first you notice that this is your set. Your set is 1, 2, 3. From this set we want four elements, okay, because we want four-digit number. So from this set we want four digits. This is what we want. From this set we want four digits, and the question is saying that these four digits you want. Now these four digits you should put in the non-decreasing order. Can anyone tell me, if I have four digits, then and I want to put them in non-decreasing order, how many ways I have? Okay, so this observation can you make? Once I have four digits, then how many ways are there to put them in non-decreasing order? How many ways to put four digits in non-decreasing order? Anyone? If I already give you, for example, if I give you four digits, let me give you four digits, and then how many ways are there to put four digits in non-decreasing order? The answer is one. Yes or no? Only one way. For example, if I give you these digits, for example, 4, 4, okay, for example, 4, 4, 3, 1, 4, 4, 3, 5. Then tell me how many ways are there to put them in non-decreasing order? How many ways to put them in non-decreasing order? How many ways are there? So only one way is there to put them in non-decreasing order. Yes or no? So this is important. So you can notice, once you have four digits, once you have these four digits, now how many ways are there? So once you have these four digits, now only one way, now only one way, now only one way to put in non-decreasing order. Okay. So basically the question is, how many ways are there to select four digits from these three digits? So the question, so I can say, so the answer, so the question is simply, so the question is simply, okay, so the question is simply, how many ways to select four digits from 1 to 3? This is the question. And now this is your multi-set question, yes or no? Can you notice what I am saying? Did you understand this question? Anyone has any doubt in this question? See, the question is saying that this is your set 1, 2, 3. From this set, you select four digits. Once you select four digits, once you have four digits, then there is only one way to put them in the non-decreasing order. If I give you four digits, if I give you, for example, if I give you these four digits, okay, let us assume that I give you these four digits. Then how many ways are there to put it in the non-decreasing order? So this is the non-decreasing, this is the only, so you can notice unique non-decreasing order you will get. Okay, so the final question is, so the question is simply, how many ways are there to select four digits? Because once you select four digits, then only one way is there. Okay, once this is done, once this work is done, then only one way is there to put in the non-decreasing order. So basically you have to find multi-set. Okay, how many multi-set of size 4 you can make from this set? Yes or no? How many ways to select four digit from this set? How many ways are there to select four digit from this set? This is your DODB problem. This is your, so this is your multi-set problem, or I can say this is your multi-set problem, or I can say this is your IODB problem. Yes or no? So you can notice basically you have one, you have two, you have three. Okay, and what we want, total we want four, total we want four digits. Okay, how many ones you are taking, how many twos you are taking, how many threes you are taking. So this is your stars and these are two your bars. So the final answer will be what? So the final answer will be 4C2. Okay, so this will be 6C2. So this will be your answer. Anyone has any doubt, you can ask. Okay, so final conclusion I can give you. Okay, so this is your IODB template. We have seen all the variations that are possible. So remember, all these problems, they have the same template. This IODB template is very 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 important. And this IODB template is followed by which problems? So this IODB template, basically in this IODB template you have IODB problem. Okay, IODB distribution. If you have to do IODB distribution, you can do that. Okay, another is multi-set problem. The multi-set counting, basically the multi-set counting also follows this same template. Okay, another is combination with repetition. Combination with repetition. Another is, what is another? That is non-negative integer solution problem. Non-negative integer solution. Okay, so this problem. And another is basically this problem, this previous problem, non-decreasing or non-increasing sequence. Okay, non-decreasing sequence problem. Okay, so these five problems, remember, these five problems, they follow the IODB template. We have seen the example of each of them. We have seen one example of this, one example of this, one example of this, one example of this, one example of this. So we have seen one example of each of them. And in the gate exam, this is a very important problem. And the next is DOIB. Okay, and for this, remember, DOIB, for these two, okay, I can say DOIB and IOIB. For these two, remember, there is no simple formula. There is no simple formula. Okay, there is no simple formula. So what you should do for these, what you should do, so do manually. Okay, basically just solve these questions, you solve manually. So for example, let's see this DOIB problem. So you have distinct objects, identical boxes. So let us assume you have four different employee and three offices. So basically you have four different distinct objects. You have four distinct objects. These four distinct objects you want to put in three same boxes, three identical boxes, three identical boxes. So your boxes are same. Okay, remember, your boxes are same. B. Boxes are same, but your objects are different. Your objects are different. Your objects are like this. Okay, so these are your objects, PQRS. These are your objects. Now tell me, just tell me this point. Okay, tell me, can I say these are different? Can I say these are different distribution? PQ is here, R is here, S is here. R is here, PQ is here, S is here. Can I say these are different? Can I say these are different? Tell me, anyone? Can I say these are different? Okay, so you can notice these are not different. These are not different because all the boxes are same. It's like in a hotel. This is a hotel room. Okay, just think like this. Okay, identical rooms. These identical hotel rooms. Okay, so these are identical hotel rooms. So this is a room. This is a room. This is a room. All these are same room. Exactly same room. Okay, so these two are basically the same, because you can notice here also PQ are together, R is separate, S is separate. Here also PQ is together, R is separate, S is separate. So these two are basically same. Okay, and tell me, is this same? Are they same? Tell me. Now these two are different. These two are different. Why these two are different? Here PQ are together. Here P is separate. So you can notice these two are different. If this is a horror movie, then in this situation R will die first, and in this situation P will die first. In a horror movie, it always happens. Yes or no? So that is the point. So you can notice these two are different scenario. Okay. So finally, what you have to do? Okay, let's see how many ways will be there. So finally, what you have to do? Remember, if you have this DOIB template, in this DOIB, just manually go. Just see, okay, one by step you go. In this, always go step by step. Okay, covering all possibilities. covering all situations, covering all situations. So what are the situations? So you have total, okay, PQRS, total 4 objects you have. So these are, let's assume these are total 4 friends, and these are 3 hotel rooms. These are exactly same hotel room, okay, exactly same hotel room. Now what you have to do? Now you can notice that, okay, so the first situation, when all are together, all these friends are together. This is the case one. First situation, when all are together. It does not matter in which room. It does not matter because all the rooms are same. So it does not matter in which room they are present. But all are together. This is matters. This matters that all are together. So now what you can do? Here I can say, okay. So in this situation, how many ways are there in this situation? Only one way, because all can go to one room. Remember, all the rooms are same, so it does not matter in which room you are there. Okay, so there is only one way. What is the another situation? What is the another situation? Another situation is 3 friends in one room, one friend separate. If this is a horror movie, this separate friend will die first. Okay, so you can notice 3 friends together and one friend separate. So how many ways are there? Again, this is very simple. So who is separate? Just find out who is separate from these 4 friends. Who is separate? So there is, okay, so only these many ways. Like who is going separate? Okay, and all the remaining 3 are together. So who is going separate? What is another way? Another way is, okay, another way is 2 friend together, 2 friend together. In this situation, how many ways are there? In this situation, can I say 4C2? Can I say 4C2 ways are there? Can I say 4C2 ways are there? Actually, no. 4C2 divided by 4C2 divided by 2 factorial. Why? Because if I say 4C2, then what it means? It will count, okay, 4C2. If I say 4C2, then these two will be counted. PQRS, RSPQ. These will be counted. If I say 4C2, then these two will be counted. Yes or no? Because if you say 4C2, what that means? See, 4C2 means is like this. Okay, so you are taking PQ, automatically RS is separate. You are taking RS, automatically PQ is separate. So you are saying, okay, these are same, but you are counting them different. So that is the reason divide by. So that is the reason we are dividing by 2 factorial. So remember, we are dividing by 2 factorial because these are basically we don't want to do double counting. So that is the reason we are doing dividing by 2 factorial. What is the fourth situation? The fourth situation is 2 together, one separate, one separate. This is another situation. Okay, so just find out who two are together. From 4 people, who two are together. The remaining 2 will be separate. So here the answer will be 4C2 ways, because just find out who are together. The remaining 2 people will be separate, will go to separate rooms. So just find out 4C2. So the answer is what? Can I create this case? Tell me. Can I create this case? This case can I create? This case is not possible. Why? This case is not possible because you have only 3 rooms. Because we have only 3 rooms. So because we have only 3 rooms, so this case is not possible. So answer is what? So the answer is very simple. So okay, here you can notice 1 plus 4C1, 1 plus 4C1 plus 4C2 divided by 2 factorial plus 4C2. So this is the answer. Is this clear to everyone? Tell me. Anyone has any doubt in this? So this is how you can do these type of questions. Now let me ask you, okay, let's do one more variation. Remember, this DOIB, this is same as finding equivalence relations. Okay, so this is same as finding number of equal, okay, finding number of this D or IB. Okay, this is same as finding number of equivalence relations. Okay, so if you want to find number of equivalence relations, then all you have to do basically this equivalence relation thing, this follows the same template DOIB. So let's see one question. Okay, so for example, how many equivalence relations are there on a set, okay, of 5 elements? So let's find this. Okay, number of equivalence relations. How many equivalence relations we have on a set of 5 elements. So you have a set of 5 elements. Remember, it's like this set of 5 elements is your 5 friends. These are your five friends. Okay. And number of equivalence relation basically means same as how many partitions you can do. Yes or no? So okay, how number of partitions, how many partitions you can do, that is your number of equivalence relations. Okay, for example, actually, for example, if I say that these are the 5 friends, okay, 5 friends are these P Q R S T, these are the 5 friends. Now if I do this partition, just think about it. If I say that PQ are together, R comma S are together, and T is together, if I take this partition, if I take this partition, this is your partition, then this partition will give you one equivalence relation. I told, okay, so this part is actually number of equivalence relations, that is same as number of possible partitions, number of possible partitions. Okay, so this you can, okay, so number of equivalence relation is basically same as number of partitions, number of possible partitions on set of set A. So for example, this is your set A, then this is a partition, this partition will give you one equivalence relation, this partition is going to give you one equivalence relation. In that equivalence relation, T will be related to T, R will be related to R, S will be related to S, R will be related to S, S will be related to R, P will be related to P, Q will be related to Q, P will be related to Q, Q will be related to P. So basically every partition is going to give you one equivalence relation. Number of equivalence relation on set A is equal to number of possible partition of set A. So how many partitions you can make? So now again, number of partitions that you can make, this is what you have to find. Number of partitions of A, this is what you have to find. Here you can apply the DOIB template. So this follows the DOIB template. Okay, because you can notice that you have 5 friends. Okay, so these are your 5 friends P Q R S T. Now we need to find how many partitions are there. So what is the first partition? In the first partition, all the 5 are together, yes or no? This is one partition, all the 5 together. In this partition, only one way is there. Okay, only one way, because all are together. Another is 4 are together, one is separate. So just find out who is separate. Just find out who is separate. So who is separate? 5C1 means who is going separate. Okay. Next, what you do? 3 comma 2 means 2 are together and 3 are together. In this situation, what is the answer? So just see who are together. I can say who 3 are together, or I can say who 2 are together. So I can say who 3 are together. Automatically the remaining 2 will be together. Okay, yes or no? Is this clear to everyone, this concept? Okay, so next, what is the another possibility? So okay, here 5 are together, here 4 together, 1 separate, 3 together, 2 separate. Okay, what is another possibility? There is no other possibility, right? So now you have to create possibility of 3, like, okay, 3 together, 1 separate, 1 separate. Here what will be the answer? Just find out who 3 are together, yes or no? Just find out who 3 are together. The remaining 2 will be separate, will go to separate. Okay, just find out who 3 are together, the remaining 2 will be separate. Okay, so there is 5C3 ways here. Next, what is another possibility? Another possibility is 2 to 1. This is another possibility, 2 to 1. Okay, 2 together, 2 together, 1 separate. Here what you do? Here the answer is very simple, that just find out who 2 are together. Okay, here, or I can say that, okay, 5C2, but I have to divide. See, okay, what I can say, I can say 5C2. Okay, so 5C2 means who 2 are together, then from the remaining who 2 are together and who is separate. Okay, who is separate, but I have to divide by 2 factorial. Why I have to divide by 2 factorial? So that I do not do over counting. I don't want to do over counting, because you can notice 2 2. Okay, so that is the reason we are doing, okay, this division by 2 factorial, so that we don't do over counting. Anyone has any doubt, you can ask. If there is no doubt, is there any doubt in this? So you can notice 2 to 1. Okay, so who 2 are together, from the remaining 3 who 2 are together. Okay, and we are dividing by 2 factorial, because We don't want to do the double counting. Here we have 2 2, so we don't want to do this type of counting. For example, this type of situation we don't want to count double counting, so we are doing double counting. So that is the reason we are dividing by 2 factorial. What is another situation? What is the another situation? Another situation is 2 1 1 1. This is another situation. Just find out who two are together. Okay, and what is the another situation? Another situation is all separate, only one way. So final answer will be what? Just add all of them. Your final answer will be just add all of them. So the okay, final answer. So number of partitions. So number of partitions possible, that is equal to number of equivalence relation possible. Okay, and this is just very simple. 1 plus 5c2, so this is just 1 plus 5c2 plus, what is this value? Can anyone tell me what this? 5c2 plus this is 3, so 5c2 is 10. Okay, so 10 into 3, that is 30. 30 divided by 2, so that is 15. That is 15 plus, and what is this? 1 plus 1 plus 5 6, and 6 plus 10 16. 16 plus 10, okay, so that is 26. So you can say 26. So here what you will get? You will get 1 plus, so this will be your answer. Okay, and you can just add. Okay, so this is going to be your answer. If anyone has any doubt, you can ask. Just go step by step. See how we have done. Plus you can notice we have done step by step. See, here all are together, means you are using only one room. Here you are using only one room. We are using here, you are using two rooms. Here also two rooms. Now here you are using three rooms, then you are using three rooms, then you are using four rooms, then you are using five rooms. So always go step by step. Okay, you using one room, using two room, only these two possibilities are there. If you want to use two rooms, then only these two possibility, yes or no? Plus Ashish, see, in this situation you are using two rooms, in this situation you are using three rooms. It's like this. Okay, in this situation it's like this: PQR are together, ST are separate. And in this situation it's like this: PQ are together, S is separate, T is separate. If this is a haunted movie, S will die, T will die. If this is a haunted movie, they will not die. So can you notice they are different? Here you are using two rooms, here we are using three rooms. So that is the reason these are different. Yes or no? Ashish, plus, is this clear? So always go step by step. That is what I am saying. I am focusing on step by step. Okay, use one room, use two rooms, use three rooms, use four rooms, and so on. Okay, now let's see what is the answer for this question. Can anyone tell me? Six distinguishable objects into four indistinguishable boxes, so that each box contains at least one object. Can anyone tell me what is the answer? Anyone? How many ways are there to distribute six distinguishable objects into four indistinguishable boxes? So this is your DOIB problem. DOIB problem. Yes or no? Distinguishable objects, indistinguishable boxes. But each box must contain. So it's like, okay, it's like six friends you have. So it's like total six friends you have, and total four rooms you have. Okay, you have total four rooms. Haunted, this is a haunted movie, and in this haunted movie you can notice there are four identical rooms, exactly same rooms. Okay, now each room must have at least one object, at least one object. So how many, okay, tell me how many partitions you can make? See, everyone must have. Okay, here you must have at least one, at least one, at least one, at least one, at least one must be there, at least one. So what are the partitions possible? So you can notice 111 must be there, 111 must be there. But now the remaining two where they will go? So maybe the remaining two can go like this. So 3 1 1 1. Or what can happen? Or what can happen? 2 2 1 1. Is there any other possibility? Is there any other possibility? Can anyone tell me? Do we have any other possibility apart from these? So you can notice there is no other possibility, right? Either you can have, okay, 3 1 1 1 or 2. Okay. So in this situation, what is the answer? From six friends, who three are together? Just find out from six friends. There are six friends. From those six friends, who three are together? The remaining will go to different rooms. The remaining will go separate. Okay, here what you do? From six friends, you select who two friends are together. From the remaining four friends, you select who two are together, and the remaining two will go to separate rooms. Now you divide by 2 factorial because of this. Okay, so you divide by 2 factorial. If anyone has any doubt, you can ask. So like this. So finally, this is your answer for this question. Okay, so this is how you can do. Just add both of them. Okay. Now, this IOIB was also same as IOIB. This is also same as DODB, DOIB. Okay. So this is actually similar to DOIB, but in this actually, what will happen? See, you have, let us assume you have AAA. These are four objects. So you can notice identical elements you have. So here you have identical objects and you have identical boxes. Your boxes are also identical. B, B, B. So your boxes are also identical. Okay. So you can notice identical boxes. So your objects are identical. Your boxes are identical. Both are identical. Okay. Now just tell me this point. Just tell me. Can I say that these two are different? A, A. Are they different? Are they different? No, they are same, right? Yes or no? They are same. Yes or no? Because they are same. Now these are different. I can say A. These are different. So these two are definitely different. Okay. So now if I have, let us assume I have 6 copies of same book into 4 boxes. So basically 6 A's you have. It's like 6 A's into 4 identical rooms. 4 identical boxes. Then what to do? Again go step by step. Very simple. This is IOIB. Basically this is IOIB. Again go step by step. Again go step by step. Okay. So first use single box. Okay, just use single box. If you are using single box, how many ways are there? Only one way. Put all the A's in that. Okay, like these are apples. 6 apples you have. Just put all these apples in that box. Okay, all these 6 apples are together. So how many ways are there? Only one way. Because all the boxes are same, so it does not matter in which box you are putting, just put them in the same box. Okay. Next, what you can do, you can put five apples together, one apple separate. You can do that. How many ways? This is interesting. Can anyone tell me how many ways? I want to put 5 apples together and I want to put one apple in another box. Then how many ways I have? So what is the number of ways? Here only one way is there. Yes or no? Only one way is there. Again, why? Because all apples are same. So okay, it does not matter which 5 apple you are taking. It does not matter which 5 apple you are putting together. It does not matter. Only one way is there because all the apples are same, all the boxes are same. So it does not matter in which box you are putting. It does not matter which apples you are taking. Okay. So 5 apples you put in one box, one apple you put in another box. Okay, what else I can do? I can do 4 comma 2. Again there is only one way because apples are same, so it does not matter in which box I am putting, which apples I am putting together. It does not matter which 4 apple are together. It does not matter which 2 apple I am taking because all the apples are same, all the boxes are same. What is another situation? Another is, okay, you can do 3 comma 3. Again there is only one way. Okay, what else you can do? What else you can do? So you can notice, okay, 5 1, you can do 4 2 3 3. That's it. Next what you can do is You can do like this, 4 1 1, like this you can do. Again there is only one way. What else you can do? You can do 3 comma 2 comma 1, this also you can do. Again there is one way. Okay, similarly you, what you can do, so okay, 5 4 and so on. So you can do 2 2 2, again there is one way. Okay, next what you can do, you can do 3 1 1 1, there is again one way. Or what you can do, you can do 2 2 1 1, again there is one way. Or what you can do, so basically just go step by step. Here I'm using 3 boxes, here I'm using 4 boxes, and I only have 4 boxes. Because I have 4 boxes, okay, so I can't do anything else. I have 4 boxes, so I can't do this. So this is not allowed, you can't do this. Okay, this is not possible. Why this is not possible? Because only 4 boxes we have, because only 4 boxes. So the answer will be what? Answer will be 1 2 3 4 5 6 7 8 9. So the answer will be 9. Yes or no? So answer will be 9. Is this clear? Anyone has any doubt in this? Quite simple, right? Yes or no? Because remember, apples are same, oranges are same, everything is same. So, sorry, what I'm saying, apples are same, boxes are same. Okay, so that is the reason it does not matter which apples you are putting together. It does not matter in which box you are putting. So these things do not matter. So that is the reason you are getting the answer is 9. If anyone has any doubt, you can ask. Okay, so you can just try this. How many ways to put 7 balls, 7 identical balls in 4 identical boxes? Okay, so anyway, you can just check it out. Can anyone tell me what is the answer for this? What should be the answer? What should be the answer? How many solutions are there for this equation? X1 plus x2 plus x3 plus x4 plus x5 equal to 21. Okay, such that x1, okay, the option A, what is the answer for option A? Option A is saying, remember, non-negative integer, but option A is saying x1 is greater than equal to 1. X1 is greater than equal to 1. And x2, x3, x4, x5, these are greater than equal to 0. So in this situation, answer will be what? Very simple. Give 1 to x1. Very simple. Okay, to this x1, you directly give 1. If you directly give 1 to x1, then what will happen? This is going to happen. x1 dash plus x2 plus x3 plus x4 plus x5. This is equal to 20 because you have already given 1 to x1. You have already given 1 to x1. Now you can just see. Now this is your non-negative integer solutions. Now very simple non-negative integer solution. Okay, so you have basically 20 stars you have and 4 bars you have. So here the answer will be 24C4. So for this option A, answer is 24C4. Correct? 24C4. And what else? What about this option B? Xi is greater than equal to 2 for all of them. So basically to everyone, to every variable, we must give at least 2. To every variable, we must give at least 2. Then very simple, to every variable, what you do, to every variable you give 2. Then what will happen? Then you will have x1 dash plus x2 dash plus x3 dash plus x4 dash plus x5 dash. What is the remaining? To every variable you are giving 2 to 2. So what is the remaining? Remaining is 21 minus 5 into 2. 21 minus 5 into 2. So basically 11. So you finally have 11 stars. Okay, so you have total 11 stars, and you have, of course, you have 4 bars you have. So finally answer will be what? 15C4. So here the answer will be 15C4. Is this clear? So both these questions are very simple, you can notice. Okay, so because here this is saying that to every variable you should give at least 2. So directly give 2. So how many are remaining? Remaining will be 11. Now these are the 11 stars and only 4 boundaries you need. Okay, how many boundaries you need? Only 4 boundaries you need. So 4 bars. 11 stars, 4 bars. So the answer is 15C4. What is the answer for this question? This is another variation. What is the answer? How many solutions for this equation? X1 plus x2 plus x3 is less than equal to 11. This is less than equal to 11. See, we have not seen this, right? Yes or no? We know what will be the answer if you have 11 equal. So x1 plus x2 plus x3, this should be less than equal to 11. What we have seen? We have seen what will be answer when you have equal. If you have equal, then we know the answer. If you have equal, then we know the answer. Okay. So you can notice in this situation, what we should do. Very simple. It's like this. Okay, it's like this. If I have 11 chocolates, just assume that these are chocolates. If I have 11 chocolates and these are three kids, and if I want to distribute these 11 chocolates to these three kids, the total must be maximum 11. So maybe for example I can give 2 to it, okay, 3 to it, and 2 to it. So how many I have given? Tell me how many I have given. 2 plus 2, okay, 2 and plus 3, so 7 I have given. Where are the remaining? Remaining are in the pocket. Remaining are in my pocket. So what I can do, this question I can say that x1 plus x2 plus x3, that is fine. The remaining chocolates are in my pocket, so the total chocolates are 11. Okay, the remaining chocolates will be in my pocket. So x1 plus x2 plus x3 plus what are the chocolates in my pocket, total should be 11, total should be equal to 11. Yes or no? So this is the idea. Very simple. Because total 11 chocolates you have and 3 kids you have. Once you give chocolates to these 3 kids, then the remaining chocolates you can put in the pocket. So this means this is your in your pocket. So I can say that x1, how many you have given to this kid, to this child x1, to this child x2, to this child x3, and plus what are in the pockets, how many are in the pocket. So total must be equal to 11. Okay, so this total must be equal to 11. So now you can just finally answer. Okay, the answer is very simple. So you have 3 bars and 11 stars. So here the answer will be 14C3. Okay, so this will be the answer, 14C3. Yes or no? Clear? So like this you can create some variations. Okay, so we have seen many questions. Okay, let's see this one question. In this one question all the 4 variations are there, all the 4 templates: IODB, DODB, DOIB, IOIB. Okay, so for example both the boxes and balls are labeled, means this is your DODB template. Here the question is boxes, balls are labeled, so this is DOIB. And you can notice here this is IODB. And what is this? This is IOIB. So can anyone tell me quickly, can anyone tell me the answer for option A? What should be the answer for option for this option A? How many ways are there to distribute 5 balls into 7 boxes if each box must have at most one? Each box must have at most one. Okay, each box must have at most one. If the boxes are labeled basically DODB. So tell me, you have 5 balls, you have 7 boxes, and each box must have at most one. Remember, each box must have at most one. Then tell me how many ways are there? Each box must have at most one. So very simple. Just select which 5, okay, which 5 boxes you want. Okay, just select 5 boxes. Which 5 boxes? Okay, select 5 boxes. Yes or no? Once you have selected 5 boxes, then 5 factorial. Because remember, this is DODB, this is DODB. This is a DODB. So I can say that first you select 5 boxes. Which 5 boxes you want? Okay. Once you have selected boxes, so this is 5 boxes. Select 5 boxes. Select 5 boxes. Now in each box you want to give one ball. Okay, so this is your permutation basically. Yes or no? Because you can note that balls are you can notice this is because of all the permutations. Okay. Okay, so like this you can do. Okay, so because you remember this point is very important. Each box must have at most one. Each box. So whatever box you select, in that box you can only give one chocolate. Okay. So for example, if you select these boxes B1, B2, B4, B5, B6. If you select these boxes, if you select now to each of these box, you can only give one chocolate. Okay, only one ball you can give. So okay, now you can do the all the 5 factorial you can do. So here you can do the 5 factorial. Okay, because this is D or DB. This is D or DB. Okay. Now tell me the answer for option B. The balls are labeled, the boxes are not. Now tell me what is the answer. Anyone? The balls are labeled, the boxes are not. In this situation, what will happen? So basically, four balls are labeled. Okay, four distinct balls you have, and seven identical boxes you have. Okay, seven identical boxes you have, but each box can have at most one. At most one. So what you can do? There is only one way. Yes or no? Just think about it and tell me. The answer is there is only one way. Here the answer is only one way, because all these are your boxes. All the boxes are same. It does not. Okay, all the boxes are same. R. All the boxes are same, and you have five different balls, and you can notice that in each box at most one ball can go. So how many ways are there? Very simple. Only one way is there. To every, okay, to what you can do. For example, you can put, okay, this ball B1 here, this ball B2 here. Okay, because the order does not. Okay, B3 here, B4 here, and B5 here. It does not matter in which box you are putting. It does not matter. So that is the reason answer is only one, because all the boxes are same. So it does not matter in which box you are putting, and each box must have at most one. Okay, so that is the reason answer is 1, because only there is only one way. And what is the answer for this? The balls are unlabeled, the boxes are labeled. The balls are unlabeled and boxes are so basically you have five identical balls. Now your ball, now these identical balls you have, and seven distinct boxes you have. So your boxes are distinct, but balls are identical. Now how many ways are there? Again you can notice how many ways are there. Can anyone tell me how many ways are there? So because boxes are different, so in which boxes you are putting? So from seven boxes, you select five boxes. So select five boxes. Okay. Select five boxes. Now, once you have selected five boxes, now there is only one way. Now there is only one way, because all the balls are identical. So the answer will be 7C5. Okay. Here the answer will be 7C5. Because just select five boxes, and in those boxes just put one ball. Okay, so that is the reason answer is this. And what is D? D means five identical balls and seven identical boxes. Then tell me what is the answer. Identical balls, identical boxes. The answer will be only one way. Okay, the answer will be here only one way. You can just check it. Okay, so these are all the distributions that you have. I hope these are clear. Can anyone tell me the answer for this? This is another variation. In how many ways I can distribute five distinguishable balls into four distinguishable boxes such that no box is left empty? Anyone? This is DODB. You can notice this is DODB. Five distinguishable balls into four distinguishable boxes such that no box is left empty. No box is empty. Then in this case, what will happen? Anyone? Try this. Try this. Anyone? So in how many ways I can distribute five distinguishable balls? Okay, so all the balls are basically distinguishable. It's like you have, these are the balls. Okay, so let's assume these are the balls. So let's assume A, B, C, D, E. These are the balls. And let's assume these are the boxes. Your boxes are P, Q, R, S. So these are the boxes. Now, no box should be empty. So what are the case? So what are the situations actually? Okay. So because no box is empty, so what you can do? For example, you can do 2, 1, 1, 1. Only this is the possibility. There is no other possibility, right? Yes or no? This is the only possibility. 2, 1, 1, 1 means one box must have two, another box 1, 1, 1. Correct? Yes or no? So this is the only possibility. 2, 1, 1, 1. Now just find out who will get 2. Okay, so this is the only possibility. 2, 1, 1, 1. Now what you do? From the four boxes you select one box. And okay, so this is the box for two elements. This is a box for two balls. Okay, so from four boxes you select one box. In this box, what you do? You put two balls. So from five balls, you select two balls and you can put here. Yes or no? So this is the box. Okay, so this is the box, and these are the two balls in a box. Okay, yes or no? So basically, first you are selecting a box in which these two balls you must put. So you are selecting a box. In this box, you are putting two balls. Okay. Now the remaining, now what? Now very simple. Now what you can do? Now you can notice that B, C, D. Let us assume this is the box A. Let us assume this is the box number. This is the box number P. Let us assume this is the box number P. Now what are the remaining boxes? The remaining boxes are Q, R, S. Now this should have one, this should have one, this should have one. Okay, so very simple. From the remaining, you give one to Q, and okay, from the remaining you give one to R, and from the remaining you give one to S. So this is your answer. So final answer will be 4C1, I can say. So here the answer will be 4 multiplied by 5C2, which is 10. Okay, multiplied by 3 into 2. Okay, so the answer will be, you can notice. Hmm? So 240 is the answer for this question. Okay, so this is the answer, 240. Okay, I hope this is clear. Like this you can do. Okay, so these questions you can just try. Okay, can I give these questions as a homework? How many ways you can buy 8 fruit if the options are apples, oranges, bananas? Can anyone tell me the template? Just tell me the template from this question. What is the template? Just tell me that. So here these are the varieties: apples, bananas, pears, oranges. These are the varieties. You want total 8. Total you want is 8. So this is your DO, this is your IODB. This is your IODB. So here these are the stars you can notice. And total how many bars you have? Total 3 bars you have. So you have total 3 bars. So final answer will be what? Answer will be 8 plus 3 C3. So the answer will be 11 C3. Okay. For this question answer is 11 C3. Next, can anyone tell me what is okay? So this is answer is 11 C3, and you can notice this question we have already done. This is also IODB. This we have already done. Okay. Can anyone tell me the answer for this? Can you take this? How many ways you can deal 13 cards? So take this as a homework. Okay, and you can answer in the comments. Okay. So take this as a homework, and you can put the answer in the comments. What is the answer? Answer in comment. Okay. So you can take this as a homework. The answer is actually this. Okay, if you want you can check. See, this is the question, this is the answer. Okay, you can just verify your answer here. So this is your actually this is the revision of combinatorics. If anyone has any doubt, then you can ask. Okay, anyone? So we will take a break, and after the break we will start the set theory. Okay, set theory, relations, and all these. So these questions I will take after the break. So at this point of time, anyone has any doubt, you can ask. So we will take a break now. Okay, and after the break, set theory revision, set theory gate questions. Okay, so many questions I am going to take, and we will see. Let me know anyone has any doubt right now. And remember discrete mathematics. So DOIB ones. See DOIB. Uh, Akash, more examples if you want. Then if you want more examples of DOIB, then can you like you can just check the discrete mathematics course on our Go classes website. This is free for all. Okay. So in this discrete mathematics course, this discrete maths. Okay, this discrete maths course actually, the complete discrete maths course, the full discrete math course, this is actually free for all. Okay, on Go classes. Okay, so there you can find many examples of DOIB case. Okay, today I think we will not be able to do graph theory. Okay, so graph theory I will record tonight, because tomorrow we have TOC revision class. Okay, in tomorrow I am going to take TOC topics. Okay, so for the graph theory, don't worry, I will record some all the complicated gate exam questions I will record. Okay, and on YouTube you can find them. Okay, generative function, here you can study if anyone want. Okay, so the full discrete mathematics course, this is actually freely available on the Go classes website. Okay, all you have to do just sign up. Okay, so just sign up and watch. Okay, so this is already available there. So if these topics, if anyone has any doubt in these topics, for example generating functions. Okay, for example inclusion exclusion principle, inclusion exclusion principle. So these topics actually you can just watch. Okay, on Go classes. Okay, 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 plus so you can watch the generative function. There is a generative function video. Just watch that lecture on the Go classes website, you can watch tonight. Okay, so here you can watch this generative function lecture and inclusion exclusion principle. These topics you can watch there. Okay, all the remaining topics we have seen. For all the remaining topics we have done the revision. Okay, and after the break we will start our set theory. Okay, the revision of set theory we will start after the break. So let's take a break and we will start at 9:50. Okay, so next session. Okay, so this is the next session. Okay, engineering mathematics is taught by Sachin. Okay, so the engineering mathematics revision class will be taken by Sachin. You can check the schedule, the revision schedule. Okay, on the Go classes website you can find the revision schedule. So today, yesterday and today we have discrete mathematics revision, and tomorrow we have TOC revision, and then you can check the schedule. Okay, so the linear algebra, okay, probability, all these topics are there. Okay, so you can just check. Any other doubt, anyone? Okay, so see you. Yes, group theory questions are already uploaded on the Go classes website. Okay, actually on the YouTube page, Go classes YouTube page, you can. I will share the playlist. Okay, group theory playlist I will share. All the most of the gate exam questions I have already recorded. Some more I will record. Okay, Sambit. So you can just watch that playlist, the group theory playlist. Okay, every gate question, for every gate question, complete analysis I have done, and that analysis is available on the Go classes YouTube page. Okay. So let you, I can write here. So you can basically see. group theory also. Group theory gate PYQ. Okay, these group theory gate PYQ you can find on YouTube, Go Classes YouTube page. Okay. Okay, thank you everyone. See you in the next session. Okay. So next session is 9:50. Set theory. Okay. Next session for set theory.